Welcome to fourth lecture in chapter 3 of our comprehensive machine learning, data science and artificial intelligence course. Now, in this lecture, we want to talk about sets. But before that, a little bit of theory. So here it is. Apologies for this bad handwriting and bad diagram, but that is because I am drawing through mouse and not drawing through stylus. That is why. Okay. So that is not using touch screen. So I am opening this pad and I am then using this mouse. Okay. Now this is suppose some collection of numbers, and it has some numbers 1, 2, 4, 1. Some numbers are getting repeated also. So 2 is coming again, 9, 12, 5, 8, 5, 2, 2, and 4. So 2 is coming many times and 4 is coming. Then this is not called a set. But from this, if someone asks you that make a set out of this collection of numbers, then you can choose only unique elements. That means find take each element, but as soon as one element is taken once, if it appears a second time, then ignore it. So you can see that 1, 2, 4, and this 1. So that I will ignore. Okay, then 2, but 2 has already come, ignore. 9, that will be added. So 1, 2, 4, then 9. 12, yes. 5 will be added. 8 will be added. Thereafter, if you see again 5 is coming, so ignore, again 2, ignore, again 2, ignore, and again 4. So that means each element should be taken one and only one time. So then 1, 2, 4, 9, 12, 5, 8. This is called a set. So set must have only unique elements. No element should be repeated. Similarly, there is suppose some other collection of number 1, 2, 11, 13. Again, some are getting repeated 2 and 1. So I can start making a set 1, 2, 11, 13. But then again 2 is coming. So don't take it. Again 1 is coming. Don't take it. 99 is coming first time. So take it. So this is my set which I have made from this bunch of numbers. Okay. Each element is unique. So that is the most important characteristic of set, that in set no element is ever repeated. Okay. Now there are some operations with that set. One operation is this, which is called union, A union B, and this is diagrammatic representation of that union. Such diagrams are called Venn diagrams. That also we know. So this left side small circle, that is A, and this right side circle is B, and they are intersecting also because between A and B some elements are common. For example, this 1 is present in A, this 1 is present in B, 2 is present in A, 2 is also present in B, like that. So that is why this intersection happens. Now A union B is very simple. Take every element of A and take every element of B and make a set. But it is also a set that you have to remember. So that means the condition for set is that every element must be unique. So how many elements will come? All elements of A and all elements of B, as long as they are unique. So these will come 2, 3rd, 4th, 5th, 6th. So all elements of A, and then all elements of B where repetition is not occurring. So these will not come. These will not come. But these 3 will come because they are not present in A. So that means that all elements of A plus new elements from B, ignore those which are already present in A, that will become the union of two sets. So 1, 2, 4, 9. 1, 2, 3, 4, 5, 6, 7, and 3 more. So I have written here 10 elements will be present in A union B. Okay, I have not written an entire comma separated list because I don't have that much space. Now then, similarly there is another A intersection B. So what is intersection of these two sets? Intersection means take only the elements which are common to both. Or here by diagram it is shown this way: left circle shows A, right circle shows B. Then these are elements shaded by blue color. They are A intersection B. And intersection is shown by this kind of mathematical symbol. But that is also a set, and it is a set of elements which are present in both A and B. For example, here this is present in A also, and this is present in B also. This is present in A also and B also. Rest of the elements, these are present in A, but they are not present in B. And similarly here 11, 13, 19, they are present in B, but they are not present in A. I want elements which are present in both. So only 1 and 2 will come. So here I have written 2 elements will come. That A difference B, it is shown by A minus B. So that is also clear, elements of A, but exclude if that element is present in B. So that means all elements of A excluding those which are present in B. So these are all elements of A, but from which I have to exclude which are present in B. So what are present in B out of these 1 and 2? So I will not take 1 and 2. So what will be all elements of A which are not present in B? Then 4, 9, 12, 5 and 8. So total 5 elements will be there. So I have written 5 elements. Okay. And diagrammatically it is shown by this. This whole blue circle, that is A, and right side blue circle, that is B. So I am shading only this much portion. I am not shading entire A. I am avoiding this portion because that portion also belongs to B. So elements here, they will be present in both A and B. So don't take those elements. Take only those elements which are present only in A, or which are present in A but not present in B. Okay. So this is the diagrammatic representation. And similarly there is A intersection B. Sorry, A what we call symmetric difference B. So symmetric difference is shown this way, that you take elements of, first you take all elements, but from them you subtract this many. Now these many are what? They are actually the intersection. Okay, this was the A intersection B, which are present in both. So take all elements except those which are present in both. So here also I will take all elements 1, 2, 3, 4, 5, and these also 6, 7, and 8. I will not take these two because they are present in both A and B. So how many elements would be there in that case? Then 5 and I think 8. So this would be 8 elements. Okay, 8 elements would be there, right? So this is what is normal set theory. Now this actually is introduced in 8th standard algebra. So ideally I should not need to do it, but this policy I have adopted. So now you can see in many of the data science courses, initially a long mathematics prerequisite is given. I have seen that what happens is that students who are sincere, they learn sincerely that mathematics prerequisite, then Python programming starts, then data science related things like algorithm, etc. starts. But by that time they forget what mathematical prerequisites are there. So I have decided to adopt this approach, that whenever a mathematical concept will be required, at that moment only I will open up this notepad like thing and I will explain that concept. And this concept will be required throughout. Okay, so that means thereafter there will be probability, and there will be some algebraic complex equations and calculus, and many statistics will be there, mean, median, mode. So I will have to explain in this manner, and then when your student sees that this is the concept and he immediately sees its application, then it is easy. So again, just quickly revising, that set means only unique elements should be present. If there are two sets, then union set means all elements of one and all elements of second also. But of course, if repetition is occurring, then you will not take them, because by definition set must have unique elements. Then A intersection B means all elements of which are present in both A and B. A difference A B means elements which are present in A but not present in B. So that, and A symmetric difference B means actually A union B, whole thing is A union B minus A intersection B. This much is A intersection B. So that means they are the elements which are either in A or B but not in both. That type of element, they are called symmetric difference. That is called symmetric difference. Okay, fine. Now let us start with our sets. Sets are another built-in data structure in Python, and they provide unique or efficient way to store unique items. This word is a new word. For list, there is no such condition. Same item can be repeated any number of times. For tuple, no such condition. For dictionary, no such condition. Same key value pairs also can be repeated any number of times. But for sets, because they are based on the mathematical concept of sets, so each item must be unique. Okay, there should be only one and only one occurrence of that item. Then they are unordered collection. This is another difference. Lists are ordered collection, tuples are ordered collections, dictionaries after Python 3.7 plus are ordered collections, while sets are unordered collection. That means there is no guarantee that today you access one element of set by its index, say 3, and after some time also if you use that index 3, then you will get the same element. Okay, so they are unordered collection. And unique means there are no duplicates that I have seen, and unordered means they do not preserve the order of the element during their life cycle. So that is one thing. They can be heterogeneous. So this is one set, and it can be number, string, integer, and floating point, and string. 3 different data types are there, but no duplication. Now these are various methods or operations which are possible. But again, as I have repeatedly emphasized, that there is no need for you to remember these things. You can just write one set, say set A, or rather my set suppose, equals, symbol is the same symbol which we use in our mathematics also, curly braces. Dictionary also uses curly braces, but inside curly braces each element of dictionary is key value pair which are separated by a colon, while here just individual elements are there. They can be string, they can be string, integer, float, anything. And then once this is written, then I can just write my underscore set, then I put dot and I put press tab, and you can see all methods of that are available. So there is no need to remember any such diagram. But I have given just so that if all are present at one place, then one can it is easy to revise things. So union, intersection, difference, symmetric difference. Then there are certain conditions, conditional functions: is disjoint, is subset, is superset, intersection, update, difference update, copy. Many different methods are. So let us do these operations: how to add elements to a set, how to remove elements from a set, and various operations: union, intersection, difference, and symmetric difference. So this is suppose my set 1, 2, 3, 4, 5, and we will first print it, and then we will add one element my set dot and press tab character. So you will immediately know that the method which is there for adding a new element is add itself. Because for certain other data structure, for example, for tuple, I think, and for dictionary also, the method was update for adding new element. For list, the method was append when you want to add, and extend. So sometimes person may forget that for this element, this data type, what was the method when I want to. So put dot and then press tab character, and you will get a list of all methods. So if I do this, then you can see original set was this, and now my set dot add, and you just have to specify the item which you want to add. Update also you can do, and update is just a list, entire list you are specifying 789. So then what will happen, it will also work like add only, but it will add multiple elements together. Okay, now that is just like in case of list, append was used to add a single element, and extend was used to add multiple elements, and inside extend the whole list of all the elements which you want to add to the list that were provided. But here we want to use not append and extend, but the methods are add and update. So when you write update, again you provide entire list what you want to update in one go, and then you write, then you can see 7, 8, 9 are simultaneously added. Now the question is, can I add one element this way? Then I showed earlier for list, and same method will work for these also, that you can use update to add one element also, but that one element must be specified as list. Okay, and then my underscore set. If you write that, then you can see one element is also added. See the difference between this add and this. Okay, here element is directly provided within the parenthesis. Here parentheses are there with update method. Every function has parenthesis, but inside the element which you want to add, that is provided as a list. If you try to provide it as without list, perhaps it will not work. Say I am adding another 11, suppose. Yes, it will not work. Okay, because it is not iterable. While update method has characteristic that its argument should be some iterable. List is an iterable, so that you have to provide. Okay, I can also try one more thing. That let me try to add some element which is repeating itself. So there are already my set and it already has 1 to 9, and I again try to add 5. So obviously it violates the condition that inside the set every element must be unique. So I try to do that, and let me see what my set gives. Here, sorry, you can see that no error is triggered. I can add 5, although 5 was already there. I can keep on adding 5, but here 5 was once, and even after adding another 5, still the new set has 5 only once. So that means it is as if the old 5 is deleted, and instead of that new 5 will be overwritten. But its occurrence remains only once, and unique occurrence. This is important characteristic of set. Now accessing an element, then for number in my set, print that number. Okay, so that will print all, because my set is just this kind of thing, and it is a kind of iterable, and for each element of that we are printing the number. It will start from the beginning of that set, and it will go up to the end. So everything will be printed this way. Okay, then if you want to remove a particular element, let me okay, let us keep it. Let me at least delete these output. Okay, then if you want to remove the 9, at present my set is like this. Okay, so I want to remove the 9, then the method is remove, and you can, if you forget, then you can write my set dot, and then you can press the tab character, and immediately it will show you what available methods are. So remove, and in which you will put the element 9 or whatever, and that element will be removed from that. Similarly, discard. Okay, now the difference, discard and then provide an element, that element would be removed. But there is a difference between these two. If 9 element which you are trying to remove is not present in your set, then in that case, let us again print my set. So it is having at present 10. Okay, but if that element which you are trying to remove, that is not there in your set, then in that case remove will raise an error that the key is not found in the set, but discard will not raise any error. It will not do anything, because if something is not present in the set, then there is no question of removing it. So let us try each in separate cells. Okay, so here remove 9, so 9 has been removed. Remember, there is no ascending, descending, or something cannot be removed from in between or any such condition. Sets have a simple condition. Each element must be unique. There should not be any duplicate. So you can remove from anywhere. But that is the reason why they are called unordered collection. Because when this was there, then this 10 was having index 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But now that one element has been removed, so index of 10 has been changed to 8. So what I'm saying is that originally if I want to access 10 from the set, then I can use index 9. But now I have to use index 8. So there is no guarantee that the index will remain same during the life cycle of set. Okay. So they are unordered, while list is ordered collection. Tuple is also ordered collection. Now my set dot discard. Now if you try to discard 10, 10 is still present, so it will discard and it will not do, not raise any message. But now again, suppose I am trying to discard some element which is not present inside. So say I try to discard 9, which is not present, then it will not give any error. But if I print my set, then it will give the same set as original, because if something is not present, then this discard will not do any change in that. Okay, so that is one difference between that. But here if I try to use remove my underscore set dot and remove, then in that case I try to remove 9, then it throws error, that key error. That means that key 9 is not found at all. Okay, so that is one important thing between that. Then this is that union, intersection, etc. So we just now saw that union means elements of first set also, elements of other set also, and the both all elements of both sets, but repetition, duplicates are not allowed. Okay, so currently what is my set? My set is this. Okay, let me put it here just for the convenience. My set is this, and what is another set? I take some other set. So this is like that set A and set B. Okay, so this is another set. Now if I do union, all elements of A will come and all elements of B will come, but repeated elements will not be included. So 1, 2, 8, then the 5, 6, 7, 8 are getting repeated, so they will not come, but 9, 10 will come. So it will become 1, 2, 10. And for union, the symbol is not U, where we write in mathematics, but the symbol is the vertical pipe operator. So if you do that, 1, 2, 10. Now intersection, there also I showed in that Venn diagram that there it will be elements which are present in both, only they will be present in the intersection set. And intersection is shown by ampersand symbol, not by that inverted capital U symbol as we use in mathematics. Okay. So if I do intersection of these two sets, it is clear that this has these many elements and this has these many elements. So what are elements which are common to both? That are the intersection. So 5, 6, 7, 8. So 5, 6, 7, 8 would be printed. Okay. And order is not maintained. It is giving 8, 5, 6, 6, 7. So that is okay, because these are unordered corrections. So it is fine. 5, 6, 7, and 8. Okay. Then difference set. So difference set means elements of this set, all elements of first set, but remove the element if it is also present in second set. So what you will remove? You will remove this 5, 6, 7, 8 because they are also present in second set. Okay. So what will remain then? 1, 2, 3, 4. So let us print, and 1, 2, 3, 4 remains. Then symmetric difference. Then symmetric difference is the elements of both, but remove the elements which are present in both sets. Okay, so that is in the intersection. So take all elements of A, take all elements of B, but remove those which are in both. So all elements of A means 1, 2, 3, 4, 5, 6, 7, 8, and these are 5, 6, 7, 8, 8, 9, 10, but remove those which are present in both. So these will be removed and these will be removed. So what will remain? 1, 2, 3, 4, and 8, 9. 8 will also be removed. 9, 10. 1, 2, 3, 4, 9, 10. That would be the output. Okay, so that is symmetric difference. Now this explanation I have already explained. This is the example where we are using sets in some functions. A very common example is deduplication. And in data science, we often need to get unique elements. Then how to find those unique elements, that is explained in this example. These two examples are there, so I am putting them in different sets. Okay. Now, first I define a function, check duplicates, and that function takes a list as an argument, and it returns the length of the list. Okay. So it just returns the length of the list. Does not return the length of the list, but it first find the set from the length from that list. So that means here I am passing, suppose one list 1, 2, 3, 1. So then this set will be only 1, 2, 3 because 1 was getting repeated, so that will not be included. So the length of the list which was passed was 1, 2, 3, 1 means 4 elements. But when you convert it into set, the repeated element is removed, so it will only be 1, 2, 3, and that means this length will become 3. But this is the length of the original list which was passed, and that was 4. So this will not match, and if they do not match, that means duplicates were found, because if these two match, then in that case no duplicates were removed. So That is what this function is trying to do. So it will return, if this do not match means false, comparison gives false. So if this returns false. So check duplicates items. Again, for explicit writing, I can write, if I want to write, is equal equals false. Then you will write that the duplicates were found. Okay, sorry. Yeah. Okay, fine. Yes, yes, yes. Output would be true in this case. So let us check it with this example. First, I will do it by manually. So 1, 2, 3, 3. This is the list, and here that function, upper function, is being called. This list is named items. So all those elements will go here. Now here len of that list. Now len of this list is the 6. But here len of set conversion of that list. So when I convert into set, this 3 will be removed because it is coming only 2 times. So 1, 2, 3, 4, 5 will remain. So that means this right side will become 5. And yes, this is not comparison, sorry, but this is not equal to. So this length is 6, this length is 5, and we are checking if they are not equal. So they are not equal. So that means the whole expression will return true. And if it returns true, so then in that case, print that duplicates are found. But this is not required. If you just write check duplicates items, then it will also be meaning same thing, that check duplicates items equals true. So duplicates found. Let me just remove that and again show you, and you will say that does not make any difference. So it is your choice. If you want to be very explicit, you can write. Now this does the same thing, but this time I am passing arbitrary number of arguments using that asterisk. Okay. So here this is the usage. Get unique elements, that is the function. Here it is defined. I pass these arguments. So that means 1, 2, 3, 4, 3. So that 3 is being repeated, so only 1 will be kept, and 4 also only 1 will be kept. And I am returning set version of whatever I am passing. So what will be returned? 1, 2, 3. Second 3 will be automatically removed when I convert to set. This 4 will also, 1, 4 will also automatically be removed. So 1, 2, 3, 4, 5 will be removed. Okay, and that you can see here. This output is not required actually. This also not required. It works like a spoiler. Okay. Then 1, 2, 3, 4, 5. That are the unique elements. Okay, fine. Explanation we have already done. And what are the practical utilities of sets? Then sets are used for removing duplicates. Sets are tests for existence of items in iterable. For example, if you want to check if an item is present at least once in a list, then also if you traverse through entire list and that list has suppose 1 lakh element, then and out of 1 lakh 50,000 are duplicated, then you are unnecessarily traveling through 50,000 additional elements because you are traveling through all 1 lakh elements. But you can first convert that list into set and then use your for loop. So then you are taking only unique elements from that list, and then you test whether some item belongs to that set version of list. A list converted into set. If it is present, then membership is confirmed. Then mathematical set operation like union, intersection, then that difference and symmetric difference. Okay, so there. Here, this discussion about set is over. So we have discussed list, tuple, dictionary, and set, and this is a brief table which compares them. Now, as such, everything in this table has been discussed, so there is no need of discussing anything. One is this thing that needs to discuss. That is, in case of dictionaries, there is no indexing because 0, 1, 2, 3 such index were not used. If you want to access individual element from a dictionary, then you should access by key only. That does not mean dictionary do not have any index. Internally, they are stored with their index, and their keys are stored by hash of there. But that key index is never used for doing various operations on dictionary. Then one more is this access time complexity. Now, in algorithms, you will learn something which is called O, big O. Big O is what? In what order of complexity the algorithm gets executed. For example, if you want to do a task, and that task is done by one algorithm with complexity O(n), and another algorithm does the same task with complexity O(n square, then the second algorithm which does it with O(n square complexity, that is called very costly algorithm, because one algorithm does it with O5 complexity and another does it with O5 square, that is O25 complexity. Then the second algorithm, O25 complexity algorithm, that will use a lot of computational resources and that will take a lot of time also to execute. So for same thing is also done not only for algorithm, for various data structure also. So that is what is written for each. That for list, complexity is O1 for indexing and On for searching. For tuple, again O1 for indexing, On for searching. For dictionary also, O1 for accessing element and On for iteration. And set have O1 only for membership test. So here searching was On for tuple. Searching is a kind of membership test only, because if you get answer that's of that search is true, that means that element is present inside the set or tuple, sorry, list or tuple. But here it is On, and On means if there are 5 elements, then 5 complexity. If there are 20 elements, then O20. Then if there are 10,000 elements, then O20 10,000. So longer the list or tuple, searching for an element would be very difficult. But in case of set, howsoever big it is, but the complexity for deciding membership is only O1, because it is hash based. In short, you can just remember that it is very easy to decide if an element is present or not for a set compared to for a list or tuple. It will take more time also, and it will take more computational resources also. So that is why, as I just now said earlier, that you first convert that list into set, or tuple also into set version of them, and then find the membership. Common use cases, everything we have done. Okay. So these also we have done. What are mutable and immutable, that also we have discussed. So some examples will be there. Example with list, example. These also we have done homogeneous, heterogeneous. Even these examples, let me check if they are some complex or not. No, I think they are not complex, so it is fine. So you can do it yourself. Yes, from here we will start next lecture, list comprehension and dictionary comprehension. And again, this is one important topic, so don't miss that lecture. Thank you.